Here's another 2D kinematics problem. You'll see a question similar to this on your next test. All right, so let's read the question. You jump off a 2-meter tall table at a speed of 5 meters per second at an angle of 20 degrees above the horizontal. How far from the base of the table do you land? All right, so we're going to start by drawing a picture. First, we'll put in our axes. So here's the y-axis and our x-axis. Now you start on top of a 2-meter tall table. So we're going to say this is our table, kind of like this. So you're on top of the table right there, and that's 2 meters tall. Okay, so then we're saying that you jump off the table at a speed of 5 meters per second at an angle of 20 degrees above the horizontal. So the horizontal above that is 20 degrees. This is your initial speed, is 5 meters per second. Okay, so let's draw what will happen to you when you jump off this table. You're going to go up flying, and then eventually you'll come back down and you'll land on the ground. And the question asks, how far from the base of the table do you land? So the question's asking you to find this point right here. Where do you land? So this is the base of the table at the bottom here, the bottom of the table. From there, how far do you land? So we're looking for that value there. I'm just going to call it x. All right, so next I'm going to make a table, and it's going to have an x column and a y column. And on the side, I'm going to put in all the kinematic variables that I know. So S initial, S final, V initial, V final, A, and delta T. Okay, so now to do my S initial and S final, those are my initial and final positions. So I'm going to just take a look at my drawing that I made. This is my initial point right here. And if I were to draw that as a point with an x and a y coordinate, I would say my x coordinate is 0 and my y coordinate is 2. So I'm going to put 0 and 2 in here. My final position is when I land on the ground. My x coordinate there, I don't know what it is, but I called it x, and my y coordinate is 0. So I'm going to put in x and 0. Then my velocity. So my velocity is 20 degrees, but it is at an angle of my velocity is 5 meters per second, but it's at an angle of 20 degrees above the horizontal. So when I'm looking for my x component, I'm looking for this vector over here. And that vector is adjacent to the 20 degrees. So it's going to be 5 cos 20. And when I'm looking for my y component, that would be opposite of the 20-degree angle. So I would say 5 sine 20. Okay, my V final is the speed that I have when I'm landing on the ground. I don't know that speed, so I'm going to just leave that whole row blank. My acceleration is that due to gravity. Acceleration always points straight down, the acceleration due to gravity, and it's 9.8 meters per second squared. So the x component of that vector is 0, and the y component is negative 9.8 because it points down. And then my time, I don't know what it is. So now I'm finished with the table. The next thing that I want to do is pick the column that has the most information. So that would be the y column, because in the x column, I have this missing piece of information, whereas in the y, I know what that value is. So I'm going to start with the y column. So I'm going to use all of these variables, and I'm going to always choose to solve for time. So this is what I'm going to find first, my time. Okay, so I'm going to write out y direction so that I know that I'm just looking at all the variables in the y column. And I know my S initial, S final, V initial, A, and I'm looking for delta T. So I look at my 3 kinematic equations, and I'm going to choose the first one, because it has all the variables I'm looking for in it. Okay, so my S final is 0, my S initial is 2, my V initial is 5 sine 20, my delta T, I don't know what it is, plus 1/2, my A is negative 9.8, and delta T, again, I don't know what it is. So now I'm going to simplify all this. I'm going to put the delta T squared term first. So when I do 1/2 times negative 9.8, I get negative 4.9 delta t squared. Now I'm going to type 5 sine 20, and I get 1.7101 delta t, and then I have my plus 2. Alright, so now I'm going to use the quadratic formula since this is a quadratic equation to solve for delta t. I get delta t is equal to negative b, so this is my b, so I have negative b plus or minus the square root of b squared, 1.7101 squared, minus 4 times a, this is my a, times c, here's my c, all over 2 times a. I'm going to type this into my calculator. So I'm going to just type in the part that's in the square root sign. So I'm not typing in square root. I'm just typing in 1.7101 squared minus 4 times negative 4.9 times 2. And I get 42.124 in that square root sign over 2 times negative 4.9 is negative 9.8. So now I'm going to type this out twice on my calculator, once with the plus and once with the minus. So I get negative 1.7101 plus the square root 42.124 equals 4.78. And now I'm going to right away divide that number by negative 9.8. And I get negative 0.4878. And then I'm going to do the same thing again, but this time with the plus sign. So negative 1.7101, sorry, this time with the minus sign. So minus the square root of 42.124 equals, I get negative 8.2. I'm dividing that right away by negative 9.8 equals 0.8368 seconds. Okay, so these are both in seconds. This is time. It makes no sense to have a negative time, so I'm just going to cross that answer out. And so my real answer is just 0.8368 seconds. All right, so that's our next step. We found time, but the question's not asking us for time. It's asking us for this x value here, which is the S final. I'm going to put my time in, 0.8368. So that's the time I have here. I can also put it in my x direction because time is not a vector. 8368, so it doesn't have x and y components. It's the same for both columns. So now I can find my S final. That's what my question's asking me for. So I'm going to work with my x direction, and I'm going to solve for my x final. So I'm going to use the same equation, S final equals S initial plus V initial delta t plus 1/2 a delta t squared. I'm going to put in all the things that I know. So S final is x, S initial is 0, plus V initial is 5 cos 20, delta t is 0.8368, plus 1/2 0, delta t 0.8368 squared. Okay, all of this just turns to 0. So it's all gone, and so now I'm just typing on my calculator 5 cos 20 times 0.8368, and I get 3.93, and that would be in meters. And so now I go back to the question. It says, how far from the base of the table do you land? So I would say, therefore, you land 3.93 meters from the base of the table. All right, so I hope that helps. Thanks a lot. Bye.